Welcome to Cadalyst SmartCasts. In this episode, we explore how GPU-powered workstations are bringing simulation to every stage of the engineering process.
Simulation has always been part of engineering and design, but how, when, and who gets to use it is changing. In the past, simulation was something done late in the design process. Models were handed off to specialists. Results took hours or even days, constrained by CPU-based systems or shared data center queues. As a result, simulation often confirmed decisions instead of shaping them. Today, that's changing. Designers now have professional workstations with modern GPUs that can take on these workloads locally. At its core, simulation gives engineers something physical that testing often cannot: insight. It's not just about whether a design passes or fails, it's about understanding why, where stresses concentrate, how heat accumulates, how fluids move, and how materials behave under real-world conditions. When simulation runs faster, engineers can explore more design options, test more scenarios, and make better decisions earlier in the process, when the cost of change is lowest. That's where the real business value comes from: better products, less risk, and faster development cycles. Modern professional workstations with GPUs can now support these GPU-native simulation solvers from enterprise software vendors. Unlike traditional CPU-based simulation, which limited how large, detailed, and frequent simulations could be, professional GPUs like NVIDIA RTX Pro on Dell Pro Max workstations use massively parallel compute, processing millions or even billions of calculations at once. Simulation software vendors such as Ansys, now part of Synopsys, have worked closely with NVIDIA to deliver GPU-accelerated and increasingly GPU-native solvers, with performance gains often 10x or 50x or more, depending on the nature of the simulation. GPU memory has also grown significantly, with up to 96 GB memory in the latest NVIDIA RTX Pro Blackwell generation GPUs. Dell Pro Max workstations configured with NVIDIA RTX Pro GPUs make higher resolution, high-fidelity simulation practical right at an engineer's desk. This shift matters because it changes simulation at two levels. At the floor, simulation becomes accessible to more people. Designers can run early, exploratory simulations inside familiar tools, screening out weak ideas, iterating faster, and understanding why something won't work. Often, this capability is already included in their software. The missing piece has simply been the right GPU. At the ceiling, high-end users can push far beyond what was once possible. Multi-GPU configurations, larger VRAM pools, and GPU-native solvers enable high-fidelity simulations that once required server or data center type of compute resources. In both cases, the GPU becomes the common enabler. And many organizations already have this capability on engineers' desks. For example, Dell workstations purchased for 3D modeling or visualization, but not yet fully leveraged for simulation. This same GPU foundation also enables the next phase of simulation: AI. Simulation data can train AI models that predict outcomes in seconds instead of hours, helping engineers iterate faster, explore more of the design space, and move closer to real-time digital twins. Whether it's optimization, surrogate modeling, or AI-assisted workflows, the requirement is the same: local, accelerated compute. Ultimately, simulation isn't just a software story or even a hardware story. It's about people having access to insight. It's about processes that support earlier, smarter decisions. And it's about technology that removes barriers instead of creating them. When those three align, people, process, and technology, simulation becomes more than a step in the workflow. It becomes a competitive advantage.
Thanks for watching Cadalyst SmartCasts. This episode was produced in cooperation with Dell Technologies and NVIDIA. To learn more about how Dell Pro Max and precision workstations with NVIDIA RTX Pro GPUs support modern engineering workflows, click on the links in the description below.